So these were the survey results. Let me see how many I actually got. Like I got like 8 or so responses.
What's assignment 7?
Yeah, session 7.
What's assignment 7? Assignment 7 and final project.
Oh, really?
On a grade book.
It's going to be like the first part of, it'll just be like your progress in the second, by next week. But it's basically the final project. So.
How do you say you did that thing
again? You go to file, you just have nothing on your screen, and then go to file geolocation, and then you'll see add location as an option. And then you just type in the address on Google Maps. You'll get to move around a little bit, just find the place, and then click, I think, select region, and then you'll get to like create a little window of where you want to snap from, and then you'll get this.
Do you have the address, or do you just check your building?
Type in 8 Washington Street. I think gets you right there. 8, yeah. Yes. Have you done something on the site before? No? Okay. Wasn't sure if another studio has done this. But it's, if you see the tennis courts, that's the site, the triangle shape. That's just to prep you guys for later in the session. So anyway, based on the survey results or the other input I got, if you guys were interested, basically what I'm looking for personally is to look at the average, min, max from everybody, but really the average to see how have these learning skills grown over the course of the through halfway of the class. So we're seeing increases in most things as I was hoping. This one here, where it's like valuation of interdisciplinary teamwork, is pretty much close, a little bit dropping. I'm wondering if that's sort of just because I've been bashing architects for the entire class, or we've been only working amongst each other. But that will certainly, I'm really curious to see how this metric looks like at the end of 183. But that's something to keep in track of. Pretty much everything else was slight increases, and looks like you guys are learning some stuff here. I got a big, clear announcement that too much material, too much in terms of the assignments, and not enough feedback. I think that's expected as well in terms of I was trying to cram a lot more than 1 unit into this. So thank you for letting me know that. The expectation of effort was a lot more than expected, and a slight growth in motivation for 183. So overall, this is giving me some idea of where you guys are at, and thanks for the written comments as well, those who gave it. So any questions on assignment 6, what we've been doing there so far? Have people used spreadsheets at all yet for any other class? Yeah, okay. Even I would have been using it for 285B, which is field design. I'm like halfway through this assignment to actually design a full moment frame. I mean, it's basically what you guys have been modeling MassSim, but now we have to actually detail every member, which takes a hell of a long time. But for some of these, like for example, I knew a Z that I wanted as part of my calculations. And so I just sort of re-rigged this spreadsheet to give me all the sections that had the minimum Z, so I didn't have to look through the spreadsheet. So I was even using this for my classes, and it turned out pretty helpful to get quick sizing of members and stuff. So hopefully this becomes effective immediately. I wanted to give some thoughts on optimization. So we did just like a handful of big data oriented exercises where we plotted rho versus normalized moment, and we got a sense of F prime C doesn't matter so much when you're actually looking at structural performance and strength. And then that's really the goal of what you can do once you've set up the calculations for the whole building. Imagine if you had that entire spreadsheet set up where you could design a 10-story steel building, and then everything was automated so that at the very beginning you could just slowly change the span of your secondary beams, or the length of your secondary beams, or the size of your overall column bays. and it would automatically show you cost. And that suddenly becomes a way to optimize data. One tool I haven't shown you guys how to use, I might show it later today or next class, but for some of those things where you've got so many calculations going on spreadsheet, and you just want to see the effect on the final value by tweaking 3 or 4 other values, you can set up what's called a data table. Have you guys used the data table before? Yeah, that's probably the best way to like see, like once you've set up all of your automated process on Excel, then you're just varying something like the span of the beams, and then you can automatically see the effect of cost. That would be really when you've entered optimization. And a way to think about at the component level, set this up as okay, so if you had to break down we've been talking about slab, secondary beam, girder, column for like a typical structural system. If you could break that down to its essential component for doing something like cost or amount of steel or amount of concrete relative to the building design, what would that look like? So let's say we've been looking primarily at buildings where we've got like 30-foot grids or something like that. Columns, we got girders, and then we've got secondary beams and slabs. So we've seen all those components. If you had to break that down, to say that between this design and say another design where instead of 2 secondary beams, you had 3, and you would just want to see like what's the effect of that single engineering choice on the overall cost of the floor, like how could you easily calculate that? You could think about a section like, say, this. If we broke this section down, there's actually quite a few of those repeating in the building. There would be basically 1, 2, 3, 4, 5, 6, 12 of them in the interior. And then this component will be slightly different. So let's call this one A and this one B. And then I guess there's a C as well in the corner. But you see why these are like slightly different components, because this one is taking just a quarter of the column, just half of the beam's width. So I'm going to draw the other half, but it's not really being taken by the component. And then the other 3/4 of the column. This is being cut off halfway through the span of the girder. And then we're also taking about a quarter of the slab with just some of the secondary beams. So let's say that in this case, there were three sections to the interior. So if you were grabbing just a quarter of that, you would only see that part of the secondary beam. So you'd see that right there. And so you could say like, this is my fundamental component, which I can get the cost or the amount of steel or the amount of rebar for that, and then just multiply that by how many times you see that in the building. And you'd have like a component for A, B, and C. And if you could automate that, then all you're really changing is the design of this, and it has like a ramification on the whole building, right? And if you were to show this in 3D, if I could draw this really quickly, you would have the slab, and then you would have like the first secondary beam, and it would be framing into a bigger girder right here. And then there'd be a girder on this side as well. And then there'd be a column back there, which is actually just a quarter of the column. So the height of this would be 10 feet or whatever your story height is. And then the lengths of these, if you were working on a 30-foot by 30-foot system, would be 15 by 15, right? So like this is like your basic component. And what you can do is, that's a great thing to model in SketchUp, because you want to at least show that amount of detail where you've designed the depth of the slab, you've designed this member, which is your secondary beam, you've designed this member, which is your girder, and you've designed this member, which is your column. There's actually a lot of information here. Architecturally, this tells you your sandwich depth of your floor, and then you can get things like cost and then quantities of steel or concrete. So start to think at how do you optimize that piece of the building, right? Because that's going to be your most typical piece structurally, right? And you really could set up a spreadsheet to have this churn out these values just by changing these guys, right? Yeah.
Does Stanford have SketchUp Pro? No, just make it's fine.
I think so. Does it have the geolocation?
Yes, yeah, it
Yes.
does. It does.
Okay, good.
Mine just expired today.
Okay.
What the hell? I didn't know I had a Pro.
Any questions on this thinking? You see the value of thinking like this? Okay. So I want to talk briefly about, like, I personally have thought a lot about exactly the challenge that faces you guys, starting really with when I took PBL, which is that CE 222, and then definitely when I was doing 183 and then solar decathlon, all these pieces. And then basically my question is, what exactly is the difference between studying civil engineering at Stanford, studying architectural design at Stanford, and then doing quote unquote civil engineering and architecture in the future if you were to go down that career path? And it's always baffled me that there just seems to be some fundamental like misnomers here or just some misdefinition of things. So I either don't actually see much of a difference, or it's like the names themselves are just segregating or fragmenting the practice itself in meaningless ways. So I just wanted to share some of my thoughts on this, and then hopefully this turns into some kind of discussion. So let's start with because I think this is important to think about because it really defines your responsibilities and roles, at least in this next class, and then like what you want to do in the future if you stay in the industry. So we have engineering. And these are like the first words we're gonna look at and really question what the semantics are, what exactly they mean. So would you first say that there's like a clean cut between these?
Yes.
Yes? Well, what is that cut? How would you define these?
Functionality versus like looking good or sex appeal.
Okay, I'm just going to call that function and form. Interesting. Anybody else contest that or add to that?
I think there's overlap wrong. Like,
Okay.
I think there's overlap.
So someone thinks overlap. What did you say, Kelsey?
Yes, there's overlap.
You contest. Okay, so there's contesting here. Why do you contest that?
Because I think both of them think a lot about form and functionality and how form is function or form follows function follows form. There's a lot of talk about that, especially in architecture, maybe less in engineering. I think the biggest difference that I see is that architecture tends to be a bigger picture and engineering tends to be smaller.
Okay. Do you contest the contest, Connor?
I think they both work with them.
Basically, what I did is I added the parentheses here as like maybe they both think about function.
I
And
mean,
form.
I would agree. I would agree that both definitely think about function. I mean, when you design a building architecturally, you're thinking how people use it, how it looks, how people interact with the space. Yeah, by all means. But I would still think that engineering is very heavily based on like, does it work? Does it stand out? Architecture is more like how it looks, how you feel. Do you have enough space?
I would almost think architecture is more like how people function in the space, and engineering is a lot of how does the space function at all, or like does the space function at all? Yes or no?
Mm-hmm.
Yeah.
I'm gonna put two words to that. I think here you're talking about use, and then here you're talking about performance.
Yeah. Oh yeah.
Anything else? Does it seem like everyone's thoughts are somewhere on here at least? Okay.
I think I would add that they both try to optimize everything.
Great. Okay. Okay. So I like the word optimization. Is there any other word, a single word that could sort of describe all aspects of a building? Let's call it building design or building engineering, but like if you're making a building exist, are there any key words that's like whether you're an architect or an engineer, besides optimization that you do? Yeah.
Sustainability, durability.
Okay. Bless you. Anything else?
Checking a lot of code.
Codes?
Both have codes.
Cost.
Lots of codes.
Okay.
Both don't want to ignore cost.
Cost. Okay.
Efficiency?
Efficiency? Okay. Anything else?
Functionality.
Okay, we can almost put form and function back here. Yeah.
Yeah.
Okay, I'm gonna move the topic over and say like all of that. Can we agree that both engineering and architecture are acts of decision making? Can we agree on that? So what are the major types of decisions you can make? It would be a lot of the ones you said just now, but then I'm gonna just make a binary difference here. Can you guys see that okay?
Yeah.
Okay, I think there's basically one binary division you can make is decisions under certainty and then decisions under uncertainty, right? So I think the certainty decisions are pretty obvious. They're like math calculations, those kinds of things. But what kinds of uncertainty decisions are there in this profession? I'll say one right away. Like, let's say you just literally don't have enough information, but you need to decide, right? Not enough information. What else?
Live loads.
Say that again?
Live loads?
Live loads.
Can never be 100% certain about your live loads.
Okay, so I'm gonna call that statistical uncertainty, or just risk.
There's a code that describes number.
So let's just put in parentheses safety factors, right? And let's not even say just code safety factors, but when you feel like uncertain, then you add your own safety factor to things, right? What else? I would actually say optimization itself is an act of uncertainty. And the reason I say that is because you can never optimize for everything. You decide what you're optimizing for, right? And what set of measures. Anything else? Say that again?
That's uncertain.
Yeah, an act of uncertainty. What about just anything that's subjective? Because what you don't know is if the client likes it.
Yeah, so like in architecture a lot, like how space will make someone feel.
Right. So could you almost say that every single act of art, is this a contested statement that every architectural decision is subjective?
Not necessarily.
Not necessarily. So
There's some architectural decisions that are like, if you put a window in, you'll get light.
right. So then, okay, so let's cross that off but would you say that a lot of what makes the news is very subjective decisions in architecture? Okay. Do you agree with calling this entire category judgment? Does that not overlap with certainty? So we can talk about engineering judgment, architecture judgment then, right? Judgment is any kind of decision under uncertainty is what I would claim.
But the architect doesn't get sued for their judgment, do they?
Oh yeah, they all the time. Building in London melted a Jaguar because they thought the curve was beautiful, but it actually was like a magnifying glass. And they had to completely change the facade because of that. By a guy named Raphael Vinoli, who I think designed something on campus here too. But it's called the walkie-talkie. And just everyone makes fun of this in London now. It's even more funny than the. No, I gotta actually put one more thing. It's not that famous yet, I guess. There we go. So that's what melted the Jaguar.
It is really cool though.
Okay.
Okay, so was the Jaguar like in a
It was on the ground.
close by or something?
And just at a certain time of day, like everything
If
was.
you go down a little bit, there's another picture that showed
Oh.
the magnification.
Oh, this.
Yeah.
Yeah. Anyway, so there was a judgment. There was a decision made here architecturally that perhaps didn't do enough analysis, right? So there's this other category we can put here, which is like analysis, right? But any contestment on just the use of the word judgment for now? Because if I use judgment again, you guys will know what that means, right? Okay. Sure.
I guess to be fair though, one thing that might go under uncertainty is just like unintended consequences. Like, I don't think anyone I don't think
Sure.
even reasonably, like, it's not necessarily something that you would reasonably think about, like, oh, are we gonna melt a car on the street with this building?
Sure.
It's just kind of.
So are you suggesting that you might make a decision under certainty, but it might have unintended
Yeah.
consequences?
The legal phrasing.
Yeah.
So if I said that certainty was like a completely understood choice, then basically this is like 0.001% of all decisions, and actually 99% of the things we do, whether we're an engineer or an architect, have some degree of uncertainty in them, right? And so you absolutely need judgment, right? At least to know how you're framing your problem. So the reason I put this up is because I like this better because this is what we really do, and it doesn't matter whether you're an engineer or an architect. Then the question is, what divides the decisions you make, right? The other thing I can ask is, if we go to two other words, so we're still in decision-making land, but now we're gonna think of the other difference we often hear is between engineering and design. So how about we do another set of definitions, and how do you differentiate engineering and design? Is there any difference?
Engineering can be more research-based.
Analytical? Okay. Contest that? Additional thoughts? Imra?
I don't think so, because you need research to design. You design your beams and columns on the steel. You need the steel research that backs up the code and the NSC code that gives you the equations.
Okay, so you just said design beams and columns. So can you engineer beams and columns? What exactly if in the way you use that word, is there a difference between these two? Or did you basically, those could be replace each other at that point? Does anyone have a very strong distinction between these two in any aspect? So then what's the difference between engineering and architecture? It's just the type of engineering or the type of design then, right? Would you say that there is engineering in architecture? Yeah? Okay, because there's entire majors and degrees called architectural engineering, right? Okay, so it's possible that there's a very, very blurred line or that almost can mean the same thing. Let me propose a 2x2 matrix in which we can plot types of decisions in the building industry, okay? So it's going to be a 2x2 matrix. Up here, I'm going to put the profession, or the sort of, let's say that if we were somehow able to put structural engineers or structure on this side, and then architecture on this side. So that's the x-axis, okay, the spectrum of these types of decisions. And then on this spectrum, let's actually put those two words again, design, and then engineering. And then we can refine or challenge this as we go. But if this is the matrix, then the first thing I'm going to claim here is that most of what we consider to be structural engineering would be like right here, at least as a class or as a degree or major. And architectural design is down here. Thoughts, comments, and reactions on that. Basically, the farthest you can be on the matrix. Okay. Any claims, contests? Okay. Then the next claim I'd make is that this is really important but untapped areas that most people don't learn in school. Okay. Agree with that? Okay. The next claim I will make is that when you, like a really strong professional in the industry, should span in one direction on this. So you're either very good at engineering, no matter what it is in the building, you can engineer it. And when we talk about engineering, let's say that these are, well, I guess we still haven't really specified what this is, but let's say that this is more certainty based. Let's say that we overlay that other spectrum we had here, and then we can, maybe these words don't exactly line up anymore, but on the scale of decisions that you're very certain about, they're almost methodical or procedural in nature. It's formulas, it's codes, it's those kinds of things. or it's just a logical step from 1 to 2. And then uncertainty is more like the things we talked about, judgment. Then you can either be like a really great engineer this way, but you're just terrible at design. Right? You need somebody to give you something, and then you figure out if it works or not. So then there's like these types of individuals that would at least be better than just being here or just being here. You can also be this kind of person, where this is somebody who just knows everything about, let's say this is like finishes and spaces and everything that would actually be under the architectural trade. And then this would be like the steel and the concrete and everything else. And here you can have like Santiago Calatrava, right? Like he builds museums, train stations, all those kinds of things that where the structure is the aesthetic. So he really is good at design, but he also engineers it all. Right? And so my first, I guess, question for you guys personally is, do you see yourself developing into one of these types of people in the future? Or it's like the ultimate prize is there such thing as somebody who could be, let's say, or a team, it could be like an I-shaped team, which is really strong, right? Because you've got the support of really good designers, really good engineers, and you've got some flow of collaboration or contact, right? And here you're just like interdisciplinary people here, right? I guess I haven't decided like if that's a better structure of 2 or 3 people or an H-shaped team where you've got really just disciplined people, like really technically know their stuff in buildings, but everyone makes really good judgment and overall decisions together. So basically what I'm trying to say is try as best as you can to develop this kind of chemistry, this or the other one in 183, either amongst you and your architects or even amongst yourselves. Because again, I would argue that we can do all of this by thinking like engineers. Like there's no such thing as a divide between engineering and architecture, because it's more like engineering happens in all aspects of the building process, and then you're focusing on different systems you're engineering or different systems you're designing. Any thoughts on that, contests? Okay. The final thing I will draw here is in the sequence of if we can plot individual decisions of the building all around this matrix, then the next question is how do you do them in sequence, right? I think back to the question of what types of decisions there are. I think what typically happens is you'll have something you're uncertain about. Well, let's do one other thing. Another way you might divide the act of engineering and design is what if design is really about asking questions, and then engineering is just about answering them. Or another way to think about it is that design is all about the question of what if, or can you, and then engineering is basically yes or no, or like in general the idea of feasibility and analysis. So this is no longer necessarily focusing on these labels, but that there are these distinct processes in the design process in doing a building. Then I would claim that these happen in a very specific relationship in the process, where as soon as you ask a question, a good question, you're really opening up a possible solution space. So like, let's say we've just asked a really good question, like what if the building has this 30-foot cantilever, or that we do this approach to spanning this depth. You've created a whole solution space within that, where then you have to make a lot of certainty or analysis-based decisions. And so sort of as you're doing analysis in here, you're going back and forth logically to all the ramifications or consequences of that what if. Like you figure out, you connect the dots, or you build the puzzle in that space you've just created with the question. And you do everything you can until you have like one puzzle piece left, which you don't know. And that's almost like you've reached that point of uncertainty. And you have to make another leap into like a new what if question. And let's say that just brings you out to a whole new dimension of your process. And then you're back to that again. And then you say like, okay, if I made that decision, then it means this, and then it means that and this, and then the building's starting to take shape. And then you go, so like, oh shit, like what if, oh now there's this big problem here. Well, what if, and then you jump to the next phase, right? And so that's a way to think about the interplay between at least those fundamental differences, answering and asking, design and engineering, I would say is at least almost like that. And then both architects and engineers absolutely should be engaged in both of those processes, right? Because in order to fill this space, you sort of have to get the whole picture, at least the whole ramification or consequences of that question. So one final diagram is who asks the first what if? Or what's the first, like the chicken or the egg question? What comes first, the answer or the question, right? We tend to think that the architect is the first one to act, right? With the first, this is potentially the party or the concept. I would argue that the first person is actually the client, right? So let's just say that anything that's more like humanities driven or like abstract, I'm going to draw as a circle. Right, so this is like the big what if, where the client has given you a site, giving you a program, given you their life story of what they want to do with their millions of dollars. And so that's like their first what if, right? So who acts next? Or who does the next action, the architect or the engineer? It's usually the architect. I am actually a strong believer that the first person to act should be the engineer. You guys can contest this, but we'll even do this today. Because it's a question of economy here. Because next I'm gonna draw as a triangle in here. Okay. So let's just say that the client usually doesn't know exactly what they want. I mean, they have this like motivation, they have the overall goals, but there's that's the largest solution space you'll ever have, because at that point anything can happen, right? Literally an infinite number of things, but that infinity is quite large. Let's say it's the size of the circle, and there's a lot of those things that are really bad ideas. Like they haven't realized that that's out of their budget or blah blah blah. So you should do a lot of like good decision making here to rule out bad options. And I think if you think about fundamental things like cost, time, like ask them the right questions there, you can do it in an engineering way and whittle down the solution space quite a bit. Then you let the architect work. Then you have to whittle down again from here, right? And the next action, let's say the architect does their concepts. Let's say that this isn't necessarily an engineer. I'm talking about the act of engineering. You're really trying to whittle down the solution space in a systematic, rigorous way, academic way. And then that could be the architect and the engineer in combination. But then you go and do another question of your own, which is what if the building looks like this? Or what if the theme of the building is this? What if the building is a walkie-talkie? Those kinds of things, right? So that's really like the first schematic concept in architecture. Then I'd say that each time I'm going to draw the engineering circle or shape, it's going to add a number of sides, and it's going to get a little bit more detailed or a little bit more closely matching what the architect's given. And let's say that then you set up the structural grid or something, right? And you've set up like, okay, this is concrete or steel. And then you're just adding, there's like this interplay. Whether or not you're an engineer or an architect, you're jumping back and forth between something that's really throwing out a possibility or an option, which is like the circle, or really deciding something under lots of uncertainty, and then seeing the ramifications of that idea, or then making that idea work, right? So any polygon is what I'd call the engineering, and then every circle is an active design. And as you can see, every time you go deeper into this, it's more closely matching what was before it, because then you're getting more limited with your options, right? Any comments or thoughts on, is this completely off, or does this sort of make sense, or is reasonable here? Okay. And again, this isn't the difference between the architect and the engineer. This is a difference in the type of thinking you're doing or the type of decision making. Okay, so that's what I've been thinking about a lot recently. The reason I'm doing this final project like this is you guys have voiced your opinion that there's way too much work. So this is going to be a very open-ended, flexible, and hopefully fun, enriching last project where you just tie everything you've learned together and really see how it works, and at least have one experience under your belt before you go to 183. But also, I really, really think you can do the whole job. Because, like I've said, so much of schematic design is that first whittling down of the options. And you shouldn't feel like architecture is out of your scope. Actually, a lot of what architects do is also decision making in an engineering way. You should feel like just as capable to make those decisions. If you feel like you're not artistic enough, or that you haven't had enough research or experience in architectural history or just the way spaces are designed, maybe that's what makes sense for the architecture profession, right? They should be, like many people said, more focused on the use, the way people use the space, the aesthetic vision, and really negotiating or doing business with the client. Maybe those are the kinds of things where people should be learning in architecture school. Because engineering as a whole, I think we should just reclaim that for the whole building, and then we can do that as an exercise. Okay. So the final project will be this site, triangular site on Embarcadero. It's exactly what we did the last time SLM taught. What I basically said is I have very little stuff here because it's supposed to be really open-ended, but let's just say the developer is frugal, so economy is huge here, and also happens to really like structures, structural aesthetics. So like you have that option of presenting that as the core concept of the design or something. And they would like to sort of know like what major structural decisions, that's really what they want to decide first. So the best value you can add to them is to show them a concept and show them why it should be steel versus concrete or something like that. There were constraints. I think these were what we had in our class, but you have to have 360 living units. I think there was more specific tiered square footage there, but let's just say on average they should be 750 square feet each. Probably be even less than that nowadays, but let's say all of that together adds up to about this much actual living space, not including circulation and stuff like that. Okay. At least 10,000 square feet of other program. I don't want to make it too complex, but like this could be anything. This could be just first floor space for lobby and anything else you would find on the first floor. You can have this be some added percentage on each living floor for shared space. It could be just entirely mechanical stuff up on the top, things like that. But just overall, it should be more than 270,000 square feet. Any other program you want to add, entirely up to you. The height limit is 500 feet from the ground. And when you actually delineate the edge of the sidewalk to the land, you have to step in 20 feet past that as well to just create a setback condition on the sidewalk. These are deliverables for March 13th, so our 12th, the final date. A SketchUp model. This should just look exactly like what you did in that second assignment, where you had multiple layers. It should show the overall form and concept of the building, where the floors are, things like that. And as much detail as you want to add on top of that. CAD or hand drawings of a typical plan and at least 2 elevations. I would suggest that, as we've done in class, you use hand drawings at the start to design, and then you present this as like a printout of the SketchUp in the right angle or something like that, or you do it on CAD or something. Because again, you understand the benefits of either of those tools. By 2 elevations, I just mean, if your building is relatively orthogonal, then pick the major and the minor axis, and then show within that drawing what that lateral system is geometry-wise. Then design the gravity load system. That's basically assignment 6. So just show me typical floors, slab, secondary beams, girders, columns. Okay. And then for columns, pick whatever the overall height of the building is. Show the lowest column, and then break it up into thirds and show me those other columns as too. So basically, that column just has to hold the weight of everything about it. Right? And then that could actually be how you tier your building. There would probably be more tiers than that, but you're at least showing that you can identify different columns sizes across the building. Design the key lateral system. You only have to pick one of them. Just pick the one that's the most demanding. Decide what it is or what combination of things it is in that direction, just with what you know. And then size those members for strength and stiffness as verified by MassDem. So when you go into MassDem, you model this, you see the forces, and that tells you the minimum strength that member has to withstand in axial or in bending moment. But you might have to upsize after that for stiffness, right? Because in almost every case in the engineering world, you reach this far to satisfy strength. And that's just so the member doesn't yield, right? But your tower might still do this without breaking. So then your next add-on is usually a little bit more or a lot more for stiffness to reduce that, right? And so your member seems like it's oversized strength-wise, but you're actually doing this just to limit this or per floor. So you should basically think of it that way. You can figure this out right away as a minimum just by plugging in the right forces in MassDem 2. And then you can either just do an iterative act here to upsize it for stiffness, or of course, as you learn more about structural engineering, you get more understanding of how to calculate this. But for now, I think it's easy enough in class to just decide what the lateral system is, put all the correct lateral forces on it. You can choose to do the second order analysis with the leaning column as well, but just get a sense of what the member should be and then upsize until this is less than whatever you have to do. Okay. Which I think in some of my reference material, you can find these kinds of numbers. So that's a lateral system. SketchUp model or hand drawing of at least one unique detail. I think one's enough for here, but it could be the foundation, which is to say that you've designed this column to withstand 10,000 kips, and that's all great for sizing the member. But then how many bolts would that take, or something like that, or how much rebar would it take to make sure that that column doesn't snap off the ground or sink into the ground? You can also just do it for some key part of your bracing system, like right there. But just tell me bolts, welds, or rebar at that level of detail for just one. And then that doesn't have to be incredibly detailed, but I just want a sense of like, is this 10 bolts or is this 100 bolts? And then either draw that like you guys have drawn in most of your assignments, or you can model that in SketchUp, up to you. You're gonna actually upload or deliver the spreadsheet in which you're doing every calculation. Just like save that and submit that and make that as organized as you can. It can just be a copy and paste of what you've done in assignment 5 and 6. And then just every visual related thing, just compile it all into one PowerPoint. So all your drawings, all your nice views on SketchUp, things like that. And then, hopefully in that process, you'll run into at least one trade-off you're making in the design, like a critical decision. I want you to like illustrate what that decision was within that presentation. So you should at least show like, like you had this option and you went with this instead, and show both of those designs or something. That's the bare minimum. So this should really just be like a walk down memory lane for everything we did up till now. You're just working with a real site, real program, and then hopefully they all sort of make sense as they fit together. Note on architecture. Obviously, you have to design this building, and don't just stack everything nicely and then say that you're done. Like, think a little bit about what types of challenges the architects will be going through at this stage, or what kind of things will be driving their decision making. I think personally, one of the most fascinating questions around tall buildings is like, there's an obvious objective need for them in places of high density, but what's the effect on quality of life? And that's usually a huge discussion on the architecture side. They're thinking about the real comfort and how that affects community and lifestyle. And that's what's driving them. Like, you guys are thinking about these kinds of things, and they're having these abstract coffee discussions about like what makes a vertical community, right? So that's what they're thinking about at this stage. And I want you to at least experience that, or at least challenge yourself to think in that route of like, what would be at least aesthetically pleasing, or something that really gets at the relationship between living units in this space. Often that means that you should bring public space up somehow and make sure that this experience isn't just getting into an elevator and then being completely separated from the 1,000 other people that live next to you. So there's questions like that, which are really architectural questions in my opinion. Okay. The structure is, how do you make that work? So challenge yourself as much as you can to think like that. Yeah.
So on the design of typical gravity load system and design of Q lateral systems, that you mean actually like sizing each member for 3 different levels?
I mean, I think, did I say it here?
Okay,
I would say make it work, and that can be conservative. Okay. But what you would start with is the critical member. And then if you can make that work, then you can say that like all the columns for the bottom half are just that size. Obviously from there you would be more efficient as you go up in the structure. But if you just want to make the stiffness work, you can just make all of the columns a certain size, or half of them a certain size and half of them a different size, and then it matches strength, matches stiffness good enough. If you had more time, you would make it a little bit more granulated. Does that make sense?
Yeah.
This should really, like, designing this should be an exercise where you're at least experiencing the tool that lets you do it really quickly. And then you understand how you would get more exact or less conservative with that design moving forward. Like in graduate classes, you would lose points if it was too conservative. Here, I don't care. At least make it stand up, right? I guess it's kind of funny because in undergrad, you're trying to get to the other side of the structural disaster. And then in graduate school, you're reeling back to get closer and closer without it falling down. So.
I mean, one day would take away points if you made it too conservative.
Oh, he would?
Yeah.
Okay.
Like he would always ask you to make it as conservative as possible.
Then use your judgment for this part. Yep.
Except this one time when you did it.
Okay. Any other questions?
And then do you want us to just look up typical line and dead loads?
So what I did was on here, all these things which are called final project, I haven't even really looked through all of this, but I think this spreadsheet just has like that kind of like class spreadsheet I was telling you guys about, where we started to create that together, but it will have values you can use. Just anything you find as wind load from 0 to 500 feet or seismic load from 0 to 500 feet. If you find it on the spreadsheet, just use it. Okay. In your 183 with a new site, you'll actually create those. For now, just assume those are given to you. And then what you want to do is, if you have a wind profile that looks like this, based on whatever the formula is for that location, then you create a similar one which is additive, cumulative, all the way to the bottom, which will look like this. So you're really just adding this and then adding here everything above it all the way to the bottom. And then this is what you really care about as your forces that you input into mass stand. Then you break this up. As many floors as you have, tributary area, turn that into point load. That's what you put into mass stand for as many floors as you have. Okay. Same, you can do the exact same with earthquake seismic loads, and I think you have that information in the spreadsheet as well. So that's what you put in with the right load combinations in mass stand.
So wait, and then we're designing like the columns and beams like we did in 181.
Yes. So for the very first time you put it into mass stand, it doesn't actually matter what you put into the members. You just get the resultant forces, and then you let that be your first sizing, and then you can be conservative right away, and then you put in all the correct ones, and that should really just be like select all on this side and make it W14 by 200 or something, right?
Right, but sizing it, like, that's a substantial amount.
Right, so...
Or what, we can just pick the biggest number and
yeah.
what?
Yeah. So start with the member down here, that force, and then that is the one time you do like the calculation, where you say like, given that moment capacity or that axial capacity, I've designed this column. Just show me to that at least for one member, and then the rest just iterate until it's under the stiffness. Okay. So like if you size the last column here, and it was like a W 14 by 900 to deal with just that axial and this bending moment you find there, then you know like, okay, I've done feasibility for the largest possible member on that frame for the purpose of just getting to a result or a design at the end of this exercise. Everything up to here is that on both sides, and then I'm going to cut it by 80% above that, and then just see what it does to this number. If it works, just leave it.
What do you mean if it works? Sorry, I don't know what you're talking about with stiffness.
If you then put all the correct members in here with their actual capacities and moment of inertia, things like that, you still have exactly the same forces in your mass stand model. So all you've done is you've changed the members to like what you think it should be. You run it again, and then you just look at displacement up here. And it falls within a range, would it be like L over some number? I don't know what it is exactly. But if it falls under that, then you've satisfied both strength and stiffness. Strength you've certainly satisfied because you've just sized the largest possible member and you've just been conservative with the rest. Stiffness will probably work at that point, but you could probably fine-tune this if you had more time. Okay. Thoughts? Does it seem like too much to manage?
I mean, designing that column itself has like many steps. Like that's like what the 181 project was. That's which was a quarter-long project.
True.
We had to do less work for 181 for the project than this one.
Have you guys designed this for concrete yet? A beam column? Is that part of 182?
Like this, I mean, we learned how to.
Okay. So like whatever homework problem does that just on its own, just input this instead and then just use that size. There should just be like a pretty systematic set of things you look for any member that experiences both axial and bending forces, and just deal with it. Again, like I just want you to have experienced the whole process. Conservative is fine with me. All right, but then the judgment gets you closer and closer to the actual number. Okay. So let's actually go through the first couple of steps. What I described as the triangle inside the first circle. So do you guys have this set up yet? Why don't we spend 5 minutes getting to this stage? Any questions on how to set up this terrain here?
What site did you say it was? What address?
Just type in 8 Washington Street or the Ferry Building or something like that. It would be this on Google Maps.
What city is that in?
This is SF. So this is Market Street right here.
Oh, I see, I see.
Okay, so if you have this site set up, this would be, we're just going to walk through the first steps together. What you would probably want to do is outline the site so that it's much more clear than the sort of low resolution image. So you want to go onto your line tool and just start from any point and just get as close as you can to what you can see of here, like where it seems like it might turn into a sidewalk or something else. And just sketch the outline of the shape. It's actually a triangle with a little kink on the lawn side. So you could say like there was a point right around there.
Derek, what's the crossroads again? The actual address?
Washington and Embarcadero.
Okay.
Wait, so it's not 8 Washington?
Is it? No.
Washington and Embarcadero?
Yeah, so 8 Washington's giving me right here. So it's this triangle right above it.
Oh. Tennis court?
Yeah, tennis courts. This was the actual site for 183 when I took it. Okay, and then what you want to do from here is just to start sketching. I think 1, 2, 3, 4, 5. 5 points is all you need to really define this shape. So like, for example, my first set of points will be this one. SketchUp, by the way, if you haven't already noticed, is if you're working off of axes which are different from your red, green, and blue, it might show you something in pink, which would just be perpendicular to what you just made. And so here I'm just going to take advantage of that because this site probably does have a right angle right there.
The map to scale in SketchUp.
Yes. Yes. Okay. And then just be as close as you can on the other edges. Goes all the way to a tip at the top. Once you've made it, it should automatically make a surface, meaning that you've hit everything on one plane. Any questions on getting to this stage? So of course, this doesn't have to be exact, but you're setting something you'll continue to use from here as just like the balance of your site. Yeah, this is super useful. And then actually, once you've set this up, you could do this later on, but you can export this back into Google Earth. It's a preview in Google Earth, and it knows where it is, and it'll just take you to the Google Earth app, and then it'll actually place your 3D model in there, which is a really neat tool. Anyway, so if you have this site set up, go ahead and sort of as practice from before, immediately make it a group. You'll probably never change that again, or you'll never change the overall bounds. And it's up to you, but usually at this point, I don't really like to have this up anymore because it's sort of distracting sometimes. You can hide that if you unlock it, or you can put it on a layer or something, but I tend to like to not look at it anymore. Although from an architectural perspective, often some of the major decisions you'll make is in relation to its context, sight lines, things like that.
Is it possible to get the rest of Google Earth in SketchUp, or do you want to take your model and put it in Google Earth?
Yeah, it's just, I think it's a computational issue here. So the more you put in, then the slower it'll be. And then if you grab a much larger region, then the resolution is like really terrible. So I usually zoom in just to what I need. And then if you want to make a quick reference, then preview it in Google Earth. You right click on it and it's locked at first, just so you can't really change its rotation or anything, but you can just right click, unlock, and then you can put it on a layer, or you can even just go ahead and uncheck the layer that's automatically been created if you want. Okay, so let's say that you're acting as sort of engineer / architect / only person working on the project so far. Oh, also, one thing I forgot to mention, you can do this entire last project individually or as pairs or as triples, I don't really care. Just have like done part of it. So what do you think, let's say that you're the only person working on this project so far, what's the next thing you would do? Like you have the largest blank canvas put in front of you. Just the client has told you, build me 360 units here, and be smart about it. That's basically all they've said, right? So based on the experience you've had so far in the class, now we are doing a little bit earlier of a phase than session 2, where we had somebody give us the architecture and we did structure to it. But what would you do at this stage? In this kind of So let's say the client has only told you what was on the document. Okay. So remember, we had the architect give us we had a form given to us in assignment 2, and then we set up floors and grid system to that, right? But what if you could just tell the architect what the best grid would be? Isn't that sort of like a rational thing to be doing as a first triangle? Like, how do you maximize your imprint or your footprint on the site itself in a rational way? And by rational, I would say orthogonal way. At least set up a grid system, right? Yeah.
We have like San Francisco like height requirements and codes.
There is. I think for this assignment in 183, we said just 500 feet max, and I've just instituted a 20-foot setback on all sides. So actually, the immediate first thing that we could do is right, exactly. So we'll get to that. So there's basically 2 really critical things you should do right at the beginning. Set the setbacks using the offset tool, and then move this guy in your SketchUp world and orient it so that the given alignments to green and red and stuff like that will actually work to your advantage. So you actually just want to like rotate your site for now into a way that's just easier to model in SketchUp with. Okay. So as soon as this shows up again, I'll show that what that looks like.
Oh, I put it on his shoulder.
You can the little guy in there. Yeah. Okay.
I put it to the center. I put it on his shoulder.
Yeah. Also, by the way, I got this overall sense as soon as I explained the assignment that there was like this huge dread of how big it is. So I'm guessing I've again overstepped the bounds of what's a 1 unit class. So let's just say that I will let you know what in this document is actually a bare minimum. I don't want to change what this is because I really think these are all important experiences, but I will say like 1 or 2 of these is like bare minimum for the points. Does that make people feel better? Okay. Okay. So the first thing to do is, let's say you want to orient this. A reasonable thing, well, actually, let's do follow the offset thing first. So just double click on the shape so that you can edit it again. And then click the offset tool, which is this one, or you can type in F. Remember, the way this works is you highlight any surface, and then you have the option of going in or out of it with an offset tool. You just click anywhere inside your shape, and then just make sure your mouse is within it, and then type in 20 feet. That's an arbitrary number I gave, which is to say that you can't put building on this strip here. Offset, or you can just type in F. So that's one very handy thing you can always do with the offset tool. And just leave it as that, exit out of the group again. It's not working, or make sure you're into the group, so you have to double click it.
Double click, offset.
Wait, you made the floor plan?
No, that's the offset.
So the shape, overall shape was that first thing we did where we just traced it, and then I hit the rest, and then now it made a surface because it was all in the same plane, and I just did the offset tool within it.
How'd you get, did you just use the move tool to get it aligned to the grid axes?
I haven't done that yet.
Oh, okay.
It's still here. That's sort of arbitrary.
Oh, okay.
Start. Okay. So I'll show you one quick thing before we actually orient the grid, because you sort of need to decide what the grid orientation is before you do that rotation action. So what are the possible rational orientations of grid we can put on this? And by that I mean that if you were to overlay a grid system of 30 feet by 30 feet, what direction is that facing? So like, let's say that to start in the global axes of SketchUp, it just gave you arbitrarily this. Like that's one orientation you can have, right? Does that make any sense on the site? No, right? So you can probably get some clues from what the actual site is, right? You can always see like what is the overall grid system. And you can see right away that it's really defined by this right angle here. So then what you would do, and this is really like, usually the architects do this. I don't see why the engineers can't make this decision. To go and say that, actually I want my grid system like that. So what you can do is you go onto your SketchUp model and you move this corner. Well, it doesn't matter which corner, but I like to move some easily recognizable point on my model to the origin in SketchUp so that it's just easy to find, easy to start from. Let's say I picked this inside corner on the street, on the lot, moved it here, and then you have to use the rotate tool from here, but get it at the origin to start. Okay. The rotate tool it looks like this. You can type in Q as a shortcut. You hover over the place you want to be the rotation, which is now, you've already defined that to be the origin. And what you should think of here is basically I'm going to now, I've clicked once so that I'm sort of just stuck to that. And then I'm just going to grab this point and move it to here. Or I can grab this point and move it to the green axis. Either of those will get you aligned.
How many feet should we space the grid? Like a rough, like 20 feet?
That's exactly that first exercise on the trace, right? So this is, again, an assumption you have to make to start. But that, whatever that activity you were doing on hand drawing is sort of what you're doing right here. You're doing it just in advance of defining the footprint. But those are entirely interchangeable, right? And you can just iterate back and forth. So that's in a completely aligned site. Again, the choice of where this lines up to the origin and exactly what you define to be globalized orientation is entirely up to you. This is your first decisions you're making, right? And as I said before, I've chosen this because that's what a lot of the adjacent buildings are orientation-wise. And it's just like, in general, I like to be parallel to something else on my footprint. right? Just so, because then later on you can maximize your building much more like that. To put a building that's angled off of your site is wasting tons and tons of space. Okay, so once you've done this, then go ahead and actually build a grid system and build it larger than your footprint, just so that you can then get a sense of what real dimension space is on your site. So usually what I like to do is I'll just draw a long green line or red line that's from one side of the site all the way to the other and past it. And right now I'm just picking the green axis because it's easy to catch with just your cursor. You make that line. And then now you basically have two objects on your space. You have the original group, which has your site with the offset within it. And now you've just made a Y direction line. And then what you want to do with this line is select it and then clone it in either direction 30 feet. Or remember, 30 is going to be our group first assumption on what the, let's say, the column spacing will be. This could be 30, 32, 34, whatever, but this is probably a nice way to start. To duplicate it, as we've done before, you can select it, click the move tool, which is this guy here, shortcut is M. The first click you make is on part of the line. I always go with the endpoint because it's easy to find. And then your next move is the vector direction in which you want to go or clone. Remember, at this point, it's probably good to type in or click Control or Command, which leaves an original one there. Remember, you can sort of move your cursor around to find the red axis. This is exactly why we did that orientation exercise, so that these intuitive guesses by Google actually help us. But again, you can also lock onto the red axis with hitting the right arrow. But just pick in one direction or the other, and then type in 30 feet as our first judgment. Click Enter, and then X some number, which will get you past the footprint. I'm going to guess 10 at the start, and it looks like it got right over. You can go, of course, as many as you want, but just you're going to make your whole field a grid. And then you can do exactly the same in the other direction. By the way, this might not be exactly the same on your model, but notice here how my 30-foot spacing was pretty darn close to my setback here, but like if I really went with this grid, I couldn't put a column there, right? And that makes me really angry because I have OCD. But just imagine if you had this condition in your architectural design and your architect placed a wall that was that far away from your grid. That's probably a great time when you can kindly ask them to move the wall, because then it would match your grid system. That's like a reasonable thing to ask, right? But site is your site, so you can't do anything about that. Once you have,
Change the grid system.
Yeah.
Since we're the architect and everything, we just change the grid system so that it matches up.
yes, but then there's a lot of benefits to having a clean grid too. Calculations look easier, construction is easier.
But
Things
I
often
think
come in.
everything like ever so slightly, make the grid slightly smaller so that it matches up.
Could. Just know that, just think about all the consequences it would have later down the line with your calculations. But yes, it's just changing your variable of L there or something. Often things like that are actually limited by architectural constraints. If you get to some point where you have to have at least a 3-foot width, or you have to have at least a 10-foot height thing, and things tend to come out into clean integers or at least halves of inches. But I think we'll experience another condition like that again, where it might actually make sense to go a little off the whole number.
Wait, so what's the problem?
This wasn't really a problem, but I was just noting, like, as you go on in the process and you notice ever a conflict between architecture and structure like this, like you can have a pretty good argument here with your architect about how they should move a wall or something to line up with your grid system.
But do walls always line up?
Not always, but the reason you usually see that is because the column's there no matter what, and that's a good place to put your wall. Because if you didn't put that, then your column would be in the middle of a room, or it would be out exposed in the middle of a hallway.
Yeah,
Right?
so your columns have to line up with the grid system?
They should. Well, the grid system is a symbolic representation you make for yourself, right? And so you can decide what your grid system lines up to. But
Right, so it doesn't matter, it doesn't have to line up.
doesn't have to. No.
Okay.
But I'd say that, yeah, the greatest benefit to setting up a grid system is then it automatically tells you where columns should go. But also remember that not every grid needs to be exactly 30 feet apart. Okay, so once you've made it all in one direction, usually I make that a group. The reason I do that is because then when you go over in the other direction, you don't want it to suddenly start segmenting everything. So the grid is going to be its own layer at some point, so we're just building that layer. The next thing to do is, once you've turned all of those into a single group, is to do exactly the same thing in the other direction. And again, we're making assumptions here on what that spacing is. We're just deciding 30 feet from now, but we can change that choice later on. So once you've made, let's say you've made the other set of lines. This one's a little bit harder to select them all. But what you can do is select everything in your space. And then you just have to deselect two things. You deselect the original footprint, and then you deselect that first group, which is all the vertical lines, or all the green direction lines. And then what you have remaining is all the red ones you made. And then you can go and right-click that and make that a group. So now we have three things on the page. We have this guy, which is all of these direction guys. We have this one. And then we have the original footprint. All of them are distinct, independent from each other. We can go back and change that spacing at any point, but they're manageable layers so they don't screw with each other. We can also grab this grid layer, both of them, and turn that into a group if you want. But basically, you've set up a really valuable layer, which you should pretty much always have in your design process. And then you can even set this up vertically as well if you wanted to. To emphasize that, I'm just going to go ahead and make two layers at this point. One layer is going to be my site footprint. The other layer is going to be my grid system. And then the way you set those into layers is you select them, you go under entity info. On the drop down menu with layer, you select the layer you want to put it in. And then once you check uncheck, it will show that or not. Okay. So again, everything is still manipulated. Everything is movable. So you can reset your grid system to line up. Let's say that one of the first things you might do is just make sure that an intersection of the grid actually lines up exactly with your origin. That's a choice you can make. Okay, any questions at this point?
Was it, how did you do the shortcut where you selected all of the orthogonal?
I selected everything, and then I deselected the site, and this is just holding shift, and then I deselected the vertical lines. Okay. One thing I'd recommend you guys start with as an exercise is to just get a sense of how much 270,000 square feet looks like in real volume. And that's in footprint and in overall height. So another assumption you want to make at this point is how high should that kind of space be? Architects always do this exercise of, I think it's usually called a bubble diagram exercise, but they'll take the client program and they'll say in scale, this is 270,000 square feet of units. And then this is 10,000 of something else. And then you can also draw this isometrically or in SketchUp as actual rectangles. But then you give these real heights, we say that when I design a program of residential, it's going to be about 10 feet high, or 12 feet floor to floor. And you're setting that up because now you're not only getting a sense of area, you're getting a sense of volume. And then let's say that this other function is probably something that could be 15 feet or 20 feet. You actually show that in 3D. I'd recommend you guys do that in the SketchUp model because that's something that the architects will be doing. And then what you can actually do is then break this up into individual units. We have that square footage of individual units, which I had it as 750 square feet. So what if we said, what is 750 square feet or divided by 30? Turns out it's 25. So you could go into your grid system. You can draw a 25-foot by 30-foot box. You can give it a height of 12 feet. And that's like an actual 2-scale unit, right? Roughly. And if at this point, I would say, hey, I just want to get an overall sense of size of what we're talking about. I'm just going to make that 30 by 30. And let's just say that includes some percentage of circulation space for that, or balcony space or something like that. But I'm just making it easy for myself. This becomes my unit building block. So if you're curious as to how much volume that takes, 360 of those, then just model 360 of them right now. Decide on how many of them would be on a given floor. Let's say that we wanted 10 on a floor. That would be 36 stories of this, right? So let's say, what if that were 2 by 5? And that extra efficiency we added by adding the 5 feet is like the hallway in the middle. Just using the clone tool here, by the way. It's just like a very first, this is the research analysis part of design, right? Let's just say that's like a very easy version of this. And let's grab that. And let's lift that up 35, x35. So that's actually a pretty good first check of what the size of your tower is. Completely efficient, nothing else, no public space. You haven't even built a lobby yet or anything. But this is your program of this, right? So it's good to do this exercise to get a first step, and then ask yourself, what if I change this? Like, okay, this is my first study. I'm going to move it over to the side. In my next study, make this here an L shape or something. Say I've got this many in this direction, and then I've got like this. That's still 10 on a single floor. I can lift that guy up. 34, 35, I think. Okay, that's study number 2. Okay, just like assembly line, move that over, move all of it over. Study model number 3. Let's say we wanted the super tall version. So what would 500 feet divided by 12 be? You could go 40 floors. So how many would be on each floor if you had 40 floors? 9. Okay. My next study model can be a 3 by 3. And I'm going to lift that up. I'm going to clone that 39 times. Also 360 units, but a new shape, right? These are all the things the architect could churn out. But you can do this now, and you've set this up so that the structural consequences are very clear. You can make very simple back-of-the-envelope calcs for things like this because you know that you've set up a grid system that's pretty consistent. The other types of study models you can make at this point are much more wild than this, right? Yeah.
I can't seem to click on only the grid.
Okay. So you can't do this?
Yeah. Selected everything, and how do I unselect the triangle shape?
You hold Shift if you're.
Shift?
I think that works on a Mac too. It might be Command. Shift. Okay. You should see this plus or minus thing on the cursor as soon as you.
Oh, it's option.
Sorry. Yeah.
But then I click.
It's so harder on the pad.
Do anything.
Yes.
You could steal this mouse.
Yes. The number one learning goal of this class is use a mouse, no matter what.
You can make them separate.
Triangular shape?
Yeah, it's a group already.
So if you think if I make a group, not include the triangle, how do I not include the triangle?
You deselect the triangle.
How do I deselect the triangle with the mouse? Like this? How do I?
Oh, you aligned it with stack corner. I see.
Yeah.
Okay. Is your triangle selected right now?
Yeah. How do I unselect it?
So hold shift. Now it should be selected. Oh, but I think you clicked on the grid though. If you zoom further in, you should be okay. So weird. Are they part of the same? It should not be. Can you move that line?
Moving the triangle.
Yeah, and then try to get one up the other. Whoa. Wait, that looked like they were part of the same group.
Why are they part of the same group? They're part of the same group. Why are they doing that?
She didn't.
It really didn't. Yeah, these lines with the triangle are in a group. I don't know how.
But now isn't it?
That's gonna be
Did you- Oh, you didn't make the original footprint.
She did.
Yeah, I did, but then I think that once I drew in the lines, it.
You were within that group.
Just delete the lines. Oh wait. Undo whatever you
Can you
already
move
did.
the triangle without moving the rest of the grid?
No, it's all.
She just unmoved it.
Yeah, well now it's all
Anyway, guys.
I don't want to make it real.
So just as a conclusion, since we're already at 8:30, is it clear that types of studies we're doing here, it doesn't matter if you're an architect or engineer, you can think of these kinds of things and you can think about the consequences. You can give some recommendations on these kinds of things. In that last example, I just did the largest block 60 feet wide as I could that was fit on the side. You just see how tall that is. Perfectly reasonable design as well. It's not a high rise as we typically expect, but it still is pretty tall. So you get at this stage and start having good discussions. You guys will decide on which one you want to choose moving forward. Please have that decided by next session. We'll have a work session. I'll try to bring some other colleagues and maybe Doug to just come in and give some critiques. And really, like I said, I don't want to overwhelm you with the end of this project. I just want you to get far enough that it has really taught you something valuable about how all these pieces fit together, and that you feel really, really confident about doing this again. So I will judge again, what is reasonable for the next 2 weeks, and it'll probably be a subset of what I posted as bare minimum. It'll be the bare minimum, and then any more is going to be good for you, and that's why you should.
Do you want us to turn in the Excel concrete design pages to you now, or do you want to wait till the end of the quarter? So I thought we were gonna build those up more, or is this project?
It's this basically. So once you send me the spreadsheet part of this, we'll basically cover assignment 6. It has those parts.
Wait, which
Okay,
one
so
is
you
it?
don't want assignment 6 right now?
I guess I'm unclear with.
The gravity, slab, secondary beam, girder, column.
You've got the
Isn't, then what is the Excel page originally, the Excel sheet, the second one?
So session 5 was playing with the tools in Excel.
Yeah.
Session 6 was starting to build the slab, beam, girder, column.
Excel sheets, right?
Yeah.
Oh, that's what's due.
Yeah. And it should be directly applicable to this.
Oh, okay.
Okay, so just at the end.
I find,
Yeah. Just plugging numbers related. You've built the spreadsheet hopefully by now. Just
Yeah.
plugging numbers related to this. And you're done.
But you want that for that assignment just by the end of the quarter
Yeah.
with this.
Yeah. Okay. And then, so there's 2 more sessions from here. The next one will be a work session. You'll come in and I'll walk around and I'll really talk to you one-on-one about your designs. Hopefully I'll have some other people. And then for the last one, I'll definitely try to have somebody in here of stature to watch the presentations. And we'll just do real quick slideshows.
So this final project is due to last day of this class.
Yeah. Remember, this is schematic. Like we're just getting the first sense of.
There's one year where you did PBL.
What year did I do PBL? 2011.
I see the gold bag, lavender and brown. I see the gold, okay, I see the black and then I see the gold, but I
Kelsey, are
see
you okay
just
with me?
blue. I don't see the white until.
I don't want to red or black, like, because good tear from just apart.
Okay, I feel a little bit better.
I don't get it, like, I don't know what the is with your brain.
Because on the computer, I saw it clear and
I asked what was
open it up on my computer.
Yeah, sure,
and I
okay.
clearly saw like gold.
Tell me what grade you want.
Because I asked her the first time, what is this? And she's like, blue and black. And I was like,
Do you want to share?
Sure, not right now, because I have to,
Later.
but yeah, sure.
How was your PBL experience? I'm in it right now.
Yeah.
And yeah, how was yours?
By the end, it was very good. Well, we won one of the challenges. So.
Okay.
But about this time, it was probably quite frustrating. And I think I didn't have that good of, I was an apprentice to the architect mainly.
Mm-hmm.
And by this time, we were having some responsibility issues where she felt like I was encroaching a little bit on, or I was like hindering her ability to design as an architect by giving too many recommendations or just getting too involved. So I remember around this time having like a hour-long or 2-hour-long Skype call with just her to like talk it out a bit. But it ended up for the better, I think, after that. Yeah. Also, probably by this time I was like building a structure for meetings and Google Docs, and I was almost jumping into a leadership role because somebody needed to like coordinate things.
Yeah, we have too many leaders.
Too many leaders, so is that better than no leaders in your opinion? Or?
I guess that we're very much process oriented and don't have much of a product. So we like to talk a lot about how.
Does it feel like the architect needs to give something more substantial at this point? Or?
Yeah, I think a lot of people are feeling that. And then we've had conversations, and the architect will say things like, "Well, I'm waiting for you guys to give me things." Like there's definitely that somewhat expected deal that happened where everyone's just waiting for someone else. But the big issue was that at the very beginning, well, not even just the very beginning, we had our mid-crit last week, and it basically told us to start over.
Really?
Because our architect was obsessed with not being too literal in the design, and like we have a lot of people with a lot of very big opinions about like what the building should be, what it should look like, and they're all kind of all over the place, and we have a lot of ideas of things. Oh, we want gray water. Okay, great. We don't have a building to put the gray water in yet. Well, okay, so how do we design the building with gray water? Like, it's not connected. Anyway, the architect was really worried about it being too, like, we've come up with our big ideas. The big idea was a tree and a leaf, and they have a bunch of connections to the culture and blah, blah, blah. It's great, big ideas. People like our big ideas. However, our architect was very much opposed to building a building that actually looks like a leaf or a tree, or had any connection to a leaf or a tree.
Okay, they want a more abstract connection.
He wanted it to be more and more abstract, and what that amounted to was building the footprint extruded. So we had box buildings, and that was it.
Yeah, well, there are consequences for every decision, but so one literal thing that could be a problem is that you just have a bad X, like a bad engineer, bad architect, like that could hinder the project. And so what you need to do in a case like that is either be as supportive as possible to making them a better X, or you do their job for them in a way.
Yeah, that's what we were talking, well, that's actually what Renata was telling us, is that there was a team here whenever ago that everyone just said no to the architect and designed the building themselves, and then brought it to the architect and said, okay, now finish it. So.
It can get to that point.
Yeah. I feel like our architect is starting to do things more better now.
Yeah.
Do you work with an actual architect?
No, architecture student.
No, architecture. But we have like a CM, and an MEP, a structural engineer, an LCFM. We have like different disciplines. So it's like 183 on steroids.
Yeah. I mean, one other big takeaway is that whether you had a good experience or not with it, you understand the value of having a good team and picking a good team that you work well with, and letting that be the most important criteria when you start a project. So for me, like I know what type of person I want to work with, and I sort of developed an understanding of that through PDL.
Yeah. It's also as an apprentice, just me not knowing what to do.
Yeah. I suggest you observe, figure out what's not working, and fix that in process. Alrighty.